Hi there. Today we're going to be building a guitar pedal using JavaScript, specifically the Harmonic Tremolo found on the Strymon Flint. Harmonic Tremolo was created by Fender in the late 50s, early 60s on their brown face amps, and it's a really sought after guitar tone. And unlike a traditional tremolo, which modulates the amplitude of the signal, Harmonic Tremolo does something a bit different. It splits the signal into two and sends one part to a high pass filter and the other part to a low pass filter. It flips the phase on the low pass and then it brings them back together and it modulates, like it pans between those two signals, giving you this amazing warm and fluid, watery sort of sound. It's more like a phaser than a traditional tremolo. So we're going to be recreating it using the Web Audio API. Let's get stuck in. Okay, let's have a quick look at the setup. I'm using a Fender Stratocaster, going into a Strymon Flint, which we're going to be using to compare and to emulate. That goes straight into a Focusrite Scarlett 2i2, which is USB into the MacBook Pro. And then I'm going to be using Google Chrome and then recording the audio using Audio Hijack. Here's the minimum viable pedal using the Web Audio API. We start off by asking for the window.audio context, and this sort of takes it into Web Audio API land. And then we get a stream, we get the get user media, which we often use for getting the webcam. But for this we can just ask for audio, and then we return that returns as a stream. We can then pipe that into a more usable source for Web Audio API through the create media stream source, where we pass the stream in and that gives us our input. And then with Web Audio API, we create things called nodes, and these are like little building blocks that we can pipe audio through, affect it, and then pipe audio out. A bit like a guitar pedal where you take your guitar signal goes in, it goes through your wah pedal, your overdrive pedal, a delay pedal, and then out to the speaker. Same sort of concept, but we're doing it on the micro here. So we're going to pass the input into this output gain node, and then the output connects back to the context of destination, which is my headphones. If I hit play, it's going to ask, do you want to use your microphone? And I'm going to say yes. And with that, we have some signal. So that's totally dry. And what we can do, just to get an idea of what we're going to be emulating, let's turn on the Harmonic Tremolo. Before we go any further with the build, let's have a look at a bit of a circuit diagram of what we're going to create. So we start with the input, that's the guitar, and we're going to split it three ways. It's going to go first to this pass-through gain node, and then that is going to pass itself connecting to the output directly. And this is going to be used as our dry signal, so no effects will happen on that. We're also going to split it to a high-pass filter, and then that will get passed to its own gain node, and then back to this summing gain node. The other side will split to a low-pass filter. We're going to flip the phase on it, and then we're going to pass that to another gain node and pass that back to the sum. Then there'll be an oscillator set for both of these outputs that will be controlling the gain. And so they're going to be working offset, so as one reduces the volume, the other one's going to increase the volume. And so we're going to get this switch, like a panning effect between the high pass and the low pass. It'll be all in mono, but it will effectively be switching between these two signals. And that's going to be controlled by like a speed knob on the pedal. And then the depth knob will control the mix between the pass-through and the summed wet signal, so the dry and the wet signal. And the more wet signal we have, the less the pass-through, and therefore the more affected the signal will be. So on the JavaScript pedal board, I have set up our tiniest little pedal. It hasn't even got any control knobs, just the switch to turn it on and off, and totally dry. Here we've just got defaults set for a foot switch that it's going to be active. This creates the DOM nodes for the button for the input switch, and then this creates the DOM for the pedal design itself, giving it a name and a title. So we have got our final output node, which is down here on the pedal diagram, and we've connected our input straight to our final output. Now obviously that's not correct, we need to build quite a bit more parts to begin with. So let's start on the pass-through. So const pass-through, equals ctx dot create gain. So we have our first gain node, and then we're going to connect the input to the pass-through, and then the pass-through is going to go to the output. Okay, if we refresh, we should still have the same sort of sound. Brilliant. Let's now create our first work down the chain. Let's go for the high pass filter first. So a high pass filter is a bi-quad filter in Web Audio API land. So let's call it high pass equals ctx dot create bi-quad filter. Now this holds all sorts of filters, low passes, shelves, band passes. We're just going to be concerned with the two today. So high pass dot type equals high pass. We can also set the frequency that this works at. So high pass dot frequency dot value equals, and let's go for 4,000 hertz. Fantastic. So that's our first point. Now let's create the high pass gain node that we leave with. Const high pass gain. Let's call it high pass out equals ctx dot create gain. Fantastic. And then we need an oscillator to work on that as well. So const high pass oscillator equals ctx dot create oscillator. Okay, those are all the parts we're going to need for this side of the chain. Let's just move these up here so all the creation is done in the same place. Next, we're going to need a summing node, and that's this part down here that the two signals get routed to. So let's create it. Up here. Const sum. It's going to be another gain node. In Web Audio API land, you tend to create quite a few gain nodes. They're super useful. So we've got our sum there. Let's work on the low pass now. Let's just call this high pass, low pass. So const low pass equals ctx dot create biquad. Oh. This one is going to be a low pass type. We're going to have an output. Let's just copy these two lines. Why not? Fantastic. So we've got a low pass output and a low pass oscillator. What we also need for this one is a phase flip. So let's create a low pass phase. That's going to be another gain node. So with the phase flip, we can do dot gain dot value. Now with a gain node, it's usually between 0 and 0 will be silent, 1 will be normal volume, 2 will be louder. What we can do is actually do -1, and that's going to flip the phase of that device and onwards in the chain. So we can use that to make that flip, and then it will go to the output and back to the sum. So let's connect these all together. So we've done our first one. We've got our input to our pass through to our output. Let's do the high pass first. We're going to do the high pass connects to the high pass output, and the high pass output connects to the sum. Finally, the sum connects to the final output. Now this is all the leg bone connects to the knee bone, connects to the thigh bone. If you can get your head around connecting nodes together with virtual cables, you can do pretty much anything in Web Audio API land. So let's do the low pass now. A bit more complicated because we've got the extra part in there, but it's not too bad. So we're going to do the low pass dot connect to the, in fact no, we first need to do an input, don't we? Input dot connect to the high pass. And then we need to also connect the input to the low pass, so it's never going to get any signal. Low pass then connects to the low pass phase. The low pass phase connects to the low pass out, and the low pass out connects to the sum. So that's a lot of connections we've done there, but it's all looking good. If we give that a refresh, play live, we should have still have some signal coming through. Now you might hear that has changed the EQ, and that's because we've got these two other filters going on. And if we were to take out the pass through, let's take out the pass through and the high pass, you'll just hear the low pass and you'll hear a really low end bassy sound. And vice versa if we did the high pass too. So that's just showing that our audio nodes are working. Next up, we need to connect our oscillators. Now our oscillators are going to be changing the amplitude of these low pass out and high pass out gain nodes. So let's do that here. Let's go for the low pass oscillator dot frequency equals, let's say it's 4 for now. Frequency dot value. Frequency is a read only, dot value is writable. And we're also going to just offset this one. So low pass dot detune dot value equals minus 180, just to offset where the up and down of the oscillator is happening. And on here we're going to do the high pass oscillator dot frequency dot value equals 4. We'll connect this up to a rotary knob in a second, but that should be that. The final two things we have to do is start the oscillators and connect them. So let's do that. We'll put it under here. Oscillator. We'll call this one pass through so we know what we're doing. So we're going to do low pass oscillator dot connect, and this time we're going to connect it to a specific value, not a whole node. So we're going to connect it to the low pass output dot gain, and then we need to start that oscillator off. Without it, it just sort of idles and waits for us to do something. Same for the high pass. So now both of our oscillators should be running, and if we refresh the page, that's sounding pretty good, to be honest. We're not a million miles away from the Strymon tone already. So now we need to create some rotary knobs to control the depth and the speed on these pedals. So there is a create rotary knob help function that I've created for the JavaScript pedal board. We pass in the pedal, the name of it, speed, the label, speed with a capital S, the maximum. Underneath this there will be an input type range that will run from 0 to the maximum, and that's just a handy way of being able to control the upper limits and the lower limits on a pedal. A value, this will be defaults dot, oh, we haven't got one, have we? Let's put defaults dot speed, and let's set the default speed to be 4. Defaults dot speed, oh, what am I doing? Speed 4, and then here, well, we've got 4, and here we can now set it to be defaults dot speed as well. Fantastic. And then finally, we have a on input function. Now this is hooked up to the on input of the input type range underneath, and it will fire out the new change of value every time we move the rotary knob. So let's just put a console log in there for now. Event.target.value, and then we will refresh this, and we should have a speed knob. And then as we move, we get values out, which is brilliant. So they're coming out as a string, so we're going to need to cast those to be a number. So let's say const val equals number. There we go. And then we need to pass these in to our oscillators. So this is going to be controlling the oscillation frequency. So if we do our low pass os dot frequency dot value equals val, and then same for the high pass. Give this a refresh. And as we turn it up, we should get to silly levels of tremolo. Bring it down. Much more sensible. Fantastic. Well, there's one of the rotary knobs. Let's do the other one. That's going to be the depth. So let's just copy and paste that in there. Depth and depth. So for this, the maximum will be 1, and that's just set as a sensible default. We want a new depth of 1, and the depth, let's say default depth is 0.7. Let's go for that. Okay, so now we need to, this is a bit different, this one. So we're still going to get the number and cast it as a, or the string and cast it as a number. And then we're going to handle the pass-through.gain.value equals, and it's going to be 1 minus val. And then for the tremolo out, the actual final output, we're going to have the, for the sum, it'll be the sum.gain.value will be whatever gets kicked out. So as we change the knob, the gain value will be 1 minus, so in inverse to whatever this value is here, and this will be obviously the value itself. So as we increase, we're going to reduce the pass-through and we're going to increase the sum, but always it's going to total 1. And it's a nice way of effectively doing a mix control. How much of the affected signal are we getting in there? And then we just need to set these as well further up when we've set up our initial nodes as well. So the pass-through and the sum, we want to have 1 minus defaults.depth, and value is defaults.depth. So with that, we should have 2 control knobs, one with a speed of 4 out of 8, and a depth set as 0.7. And let's have a listen to that. Sounding good. Let's turn down the depth. This should be less affected. And then up to full. This is fully wet. It's quite intense. Let's just reduce that ever so slightly and up the speed. Brilliant. Okay. Well, let's just set that to being something a little bit more chilled. Speed of 4.4. Let's have a listen to this versus the Strymon. So let's put the Strymon on first. And then our JavaScript version of it. More depth in ours. That sounds pretty good to me. Let's see how it sounds in situ with the rest of the pedals. We've got a bit of delay, some reverb, and the harmonic tremolo.